Hi and welcome to this lesson of chemistry, and in this lesson we will look at different types of bonds. What do I mean when I say bond? Well, I mean that if I have an atom has the ability to interact with other atoms to form a bond, okay? They kind of get stuck together and form a new substance, okay? It can be 2 atoms, it can be 3 atoms, there can be many atoms that bond together. Now we get different types of bonds, and that's what we will look at in this lesson. But first of all, let's quickly see why do bonds occur. You might recall from the previous lessons that all atoms want to be noble. Atoms want to be noble. What we mean by that is all atoms want to revert to an electron state that is like the noble gases. Now, the noble gases have their highest energy level filled to the brim with electrons. So they have no more space in the highest energy level to take more electrons. We looked at that in the previous video. Now, what that means is if I have an atom like sodium, or let's start with chlorine. If I had an element like chlorine, chlorine has, in his highest energy level, 7 electrons. The noble gas, in his case, is argon. He wants to be like argon, and argon has 8 electrons in his highest energy level. These electrons in the highest energy level is called the valence electrons. So his 7 valence electrons wants 1 more, and then he will be noble. Now the question is, how will he get it? Well, he can either share this one that needs a pair with someone else, and that other one could share it with him. And an example of that would be hydrogen. If we look at hydrogen, hydrogen has only 1 valence electron, and hydrogen wants to be like helium. Helium has 2 in his highest energy level, because level 1 can only take 2. So what these two can do is they can kind of share their valence electrons, okay? So they can kind of share it, and then both of them will be happy, okay? Like that. Now you can see chlorine has 1, 2, 3, 4, 5, 6, 7, 8. Okay, chlorine has 8 electrons, and hydrogen has 2 electrons because they are sharing this. This is called a covalent bond. Okay, covalent bond. And in a covalent bond, we are sharing our atoms. Okay, or sorry, not our atoms, our electrons. Covalent, that co means together, okay, and valent obviously refers to the valence electrons. So we use our valence electrons and share them in order to fill up our energy levels. However, that's not the only way in which this can bonds can happen. We don't just have to share. We can maybe take an electron from another element. Let's look at the element sodium. Sodium, Na is for sodium. Sodium is in group 1. If we look at our periodic table, sodium is here in group 1, which means he has 1 valence electron. If he can lose that 1, he will go back 1 level and be like neon. So he has 1. If he can lose this 1, what will happen is now all of a sudden he will have more protons in his nucleus then he will have electrons, because he's lost an electron, and a neutral element has the same number of protons than electrons. He's lost an electron, which now makes him a positively charged particle. Now, I haven't mentioned this before, but charged particles are called ions. Okay. An ion is a charged particle. So now we have an ion. A positive charge is called a cation, and it's not with a K, it's a cation. And a negative charge is called an anion. Okay, So what would happen with this one electron? Where would it go? Where would he give it? Well, he needs to give it somewhere. It can't just be eliminated from his structure. So he could give it to chlorine. Okay, if chlorine were to receive that extra electron, okay, he used to have 7. Now he takes this extra one from sodium, and now he's got 8. But remember, in his nucleus, he still only has 7 protons. But now he's got 8 electrons. This means that chlorine gets a positive charge. So chlorine, sorry, not a positive charge, a negative charge. He's got more electrons than protons, so he becomes now negatively charged. Because these two ions, so this becomes an anion, because these two ions now have different charges, we know that the law of electrostatics says that ions, opposite charges will attract each other. There's an attractive force between these two ions, and they form now a new substance called sodium chloride. Okay, so if we had our sodium atom or our chlorine atom, and now we have our sodium atom, slightly smaller. Okay, they're now attracted to one another and they form a new substance called sodium chloride, or better known to you as table salt. Okay, that's actually table salt. Now, this new thing that is formed is not called an atom anymore. It is now called a molecule. A molecule is a bond, or is bonded atoms. Okay. This type of bond, where I have ions being attracted, opposite charged ions being attracted to one another, is very simply called ionic bonding. And ionic bonding. So at this stage we know of two types of bonding: covalent bonds, and that is where we share our electron, or ionic bonding, where it's not sharing our electron but actually giving away our electron to someone else that needs it, and that's called ionic bonding. Now, all bonds aren't 100% ionic and 100% covalent. They're more on a scale. Okay, so if we had our covalent bonds here and we have our ionic bonds there, okay, a reaction that creates a molecule can be somewhere on the scale, and where it is on the scale depends on the electron negativity of the two items. Let me explain. You'll remember that we said that electron negativity is the ability to attract an electron. Okay, so let me write it here. Okay, so electron negativity, it's actually one word, I'm sorry. Okay, is the ability to attract an electron. Okay, so we know that if we look on our periodic table, we can see fluorine is almost 4. His electron negativity, I don't know if you can see that, but is almost 4. He's got the highest electron negativity, meaning that he has the highest ability to attract electrons. The lowest one is this one down here. I don't even know what that is. Francium. Francium has the lowest electron negativity, an electron negativity of 0.7, which means he's the least likely to attract electrons. That doesn't mean he's not likely to react, because if he is not likely to attract electrons, it means he's very likely to give it away. So he's very frantic about giving away his one electron, and fluoride is very frantic in getting one extra electron. Now, because this one is so likely to give, and this to get, and this one is so likely to give, if I look at their electronegativity, I would see that the gap between them, the difference between them, is probably the largest than between any other two. What that means is that this one is very likely to take, this one is very likely to give, so that means this one is very likely to become an ion, and that one is very likely to become an ion, making the reaction between these two an ionic bond. That's probably the strongest ionic bond that there can be. Okay. If, however, I look at the purest covalent bond, let me show you the purest covalent bond, in other words, a bond that is the least ionic bond. That would be an example like this. Hydrogen cannot just exist as a substance without having its highest energy level filled. So in order for hydrogen to exist as a substance, he needs to get another electron. What he could do is get it from another hydrogen. So two hydrogens can share their one electron among one another, producing the gas hydrogen, and the gas hydrogen is then called H2 because the gas hydrogen consists of hydrogen molecules, two H molecules, and the two H atoms, and the H atom is literally the smallest atom that exists. Two H atoms together share their electrons and form a hydrogen molecule. Now this is the purest form of covalent bonds. In this case, you could more or less consider chlorine to become slightly positive and hydrogen to become slightly negative, hydrogen to become slightly positive. Not exactly, but there is a sense of an ionic bond here. But here there's definitely simply sharing the one electron between one another, which means that this is the purest form of covalent bond. Now, what is the difference this time in their electronegativity? Notice that this electronegativity, 2.2, if I were to take the difference between hydrogen and hydrogen, the difference would be 0. Okay, so maybe I'm losing you a little bit, okay, but what I mean is, if I take the electronegativity of my first element minus the electronegativity of another element, okay, element 2, the value that I get here, the bigger that value is, okay, the larger this value is, will create an ionic bond. It's more likely to be an ionic bond. The smaller that value is, okay, in other words, it's getting close to 0, and here the biggest the difference that you can have is 3.3. okay, so the closer the difference is to 0, that's obviously taking the bigger one minus the smaller one, okay, the closer it is to 0, the more it is a covalent bond. The closer it is to 3.3, the more it is an ionic bond. Okay, so if we look at chlorine and hydrogen, okay, chlorine has 3.16, hydrogen is 2.2, so if we take chlorine and hydrogen, 3.16 minus 2.2 gives me that is roughly 0.94. I think so, 0.94, and you can see that would be somewhere here on this scale. So it's more a covalent bond than it is an ionic bond. Well, I hope this makes sense to you. This is a great lesson for me to teach. I really enjoy it. It makes sense to me, and I hope I've been able to make it makes sense to you. Good luck in trying to identify covalent or ionic bonds.